For scientific computing, MATLAB is an often used numeric computing environment. This STRUREL online presentation is about how to employ a MATLAB-based limit state function in STRUREL. This online presentation specifically targets MATLAB. However, interfaces to many more programming languages are available in STRUREL. Before we can use the MATLAB interface of STRUREL, we should ensure that it's configured properly. For this, please go to the directory in which MATLAB is installed. Go to the subdirectory bin and copy the path of this directory into your clipboard. Remember that there is a Win64 directory also contained in bin. Then right-click on System and select Properties. Go to Advanced System Settings. Select Environmental Variables. Select the path variable and click Edit. Add a new entry and paste the content of your clipboard in there. Then add another entry. Again, paste the content of your clipboard in there and append Win64. Select OK, OK, OK. Make sure to restart COMREL after you change the path variable of Windows. Now, you should see the MATLAB icon appearing in the status bar of COMREL. If this is not the case, or there is only a red cross there, make sure that the path to the MATLAB installation is set correctly in COMREL. For this, go to View, Preferences, select Add-ons, and ensure that the path specified under MATLAB points to the directory in which MATLAB is installed and to the subdirectory in which libenc.dll is located. Now, let's do a simple test example. In a project directory, we create a new MATLAB script file, which we call mymodel1.m. We open this script file and put a MATLAB function in there, which returns a value called lsfval for value of the limit state function, and the function is called mymodel1 and takes input vector input. Inside of this function, we want to use the global random variables r and s. This will be exported by COMREL later on, and we have to ensure in our COMREL model that these two variables r and s are indeed defined inside of our COMREL project. So the limit state function is then simply the difference between r and s, where r represents a resistance variable and s is a load variable, and failure occurs whenever the load is larger than the resistance, meaning when the limit state function becomes negative. We save this simple MATLAB function and then go to COMREL and create a new project. And now here in the stochastic model, we have to define these two random variables r and s. And we have to make sure that the naming of them, r and s in this case, is exactly the same as the names that we used in the MATLAB script file. Our resistance variable r is a log normal random variable with a mean value of 5 and a standard deviation of 1. And the load is a normal random variable with a mean value of 2 and a standard deviation of 0.5. In the symbolic expression tab, we define the first limit state function as a MATLAB script file. So we use the command matlab-s. Inside this function, we specify the name of our MATLAB script file, so my model 1 without the .n. Let's save it. Make sure that you save it in the same directory that also contains your MATLAB script file. We parse it, and now we should be able to run the reliability analysis. It will take a bit now because MATLAB needs to start, or Comrel needs to start the MATLAB engine. And then we see this results from a form analysis where we get a beta value of 3.2 and the probability of failure around 7 times 10 in the power of minus 4. So let's try another alternative approach with a slightly different MATLAB script file. We copy the original file and give it name mymodel2.m. Then we go to Comrel and define the second limit state function again with MATLAB-s, and this name of the script file we give it now mymodel2. Let's save it, parse it, and then you see this second script file appearing here. And now if you right click on it, we can use edit and use the internal script editor of Comrel. Let's change the name mymodel1 to mymodel2 and get rid of the global random variables r and s. And instead of the global variables, we now use the input vector called input. So we can define r also as the first entry in the input vector and s as the second entry in the input vector. The ordering of the random variables in the input vector is equivalent to the ordering of the random variables in the stochastic model. So here r is the first random variable and s is the second random variable. I want to show you the debugging feature of Comrel. So I wrongly define input with square brackets. Let's save it, parse it again, and then let's run the second limit state function. And now MATLAB complains right away that in line 3, column 12, there is a bug. We have the indexing variable, which is defined with the wrong parentheses. So let's fix this, save it, and then run it again. And we get exactly the same result as we got before. We can also cross-check this. As the limit state function is so simple, we can simply use the internal symbolic expression of Comrel, simply r minus s. Let's parse it again, save it, and then run the third limit state function, which again gives us exactly the same result. If you watched this far, I'm sure you like this channel, so hit the subscribe button.